So in this presentation, we are tasked with talking about what makes a good hash function. And when I think about this, I think about how it's used for passwords. We're going to use this example test, which I know is not considered a strong password, but we're just going to use this to show how different hash functions will deal with this input. Um, and the link is below that will show all the hashes just for this simple input. So here's some examples of some hash functions or some categories. And the biggest benefit of this is why we want them is because we can find data a lot faster. So the time in finding the data is O of n instead of O of log n, as many of the other comparison algorithms. So that's the biggest reason why we want this. So we have the categories of weak, middle of the road, and good. Just simple stating as what they are is that even though the hashing algorithms may work, when it comes to security, they're not very good. The weak ones are the MD4, MD2, MD5, and SHA-1. The middle of the road is the RIPE, and then the good ones are the 256 and Whirlpool, which is Windows specific. So when I talk about passwords used for hashing, I mean, there's multiple things that we use for hashing. Really, when it comes to searching, hashing is used a lot. Um, Looking up dictionaries, spell check. It was this couple examples that was used in some of the videos that was the YouTube videos. But one of the techniques I saw when it comes to password protection is randomization, a technique called SALT. So SALT is usually literally what that means is uh, there might be, for example, a user that has three different users that uses the password test, but the SALT method uses different algorithms to hash the same password to avoid collision. Collision is the main issue when it comes to hashing, and several of these techniques, of these hashings that we'll talk about, deal with collision. Some of them don't deal with it very well. Some of them do a good job with it. And all that means is that we don't want duplicate data um, at all, if possible, would be the best case scenario. But it's going to happen occasionally, but we want to try to avoid it as much as possible. And we'll talk about some of these hashing methods and kind of how they deal with that and how they try to prevent that. So, and like I said, the main thing with the passwords, even though the passwords may be identical, like I might use the word password, the salting method will randomly choose which hashing algorithm it's going to use in order to jumble up that password. So even though the password text is exactly the same, the actual hash and what's stored on the server is different, and that's going to help prevent hacking. So here's the example of the word test. Like I said, with all the different algorithms I mentioned earlier, this is just a screenshot from the website. I typed it in, I hit calculate hashes, and this is what it produced. I'm not going to go through each individual one of these, but as you can see, none of them are exactly the same. So if you had a algorithm like SALT, for example, that randomly chose from all these hashes, you can see even though we're using the same password, so to speak, across the board, each algorithm has its own hash method. So some of these are going to be more secure than others, but the main thing is when you watch the videos and when you talk about hashing, the main thing that you want is you want them randomly chosen throughout. And again, that's going to help avoid collision. So pros and cons, like I mentioned before, your bad ones are fast but not secure, middle of the road, more secure but not as widely used, and the best ones are more secure, prevent collision, but they're much slower. They take up more space, but really for your purposes, if you're looking into uh, cryptography, for example, password protection, I would think I would want to use the more secure ones. So again, sources below of summary of some of these. MD2 is one function. It uses 16-byte blocks in checksum addition. That's one of the things that it does. 18 rounds go through to produce that output that we had earlier. There's some sources below for that information if you want to read more about that. MD4 input in 512-bit blocks, 3 rounds of nonlinear functions, produces 128-bit output. It's faster than MD2. So MD5, it's faster but it's not as secure. And so when I think about this, so it talks about here about comparing hashes to ensure data integrity. So if I was a hacker, for the way I think about this, if I was a hacker, for example, trying to hack this, and even manipulate the hashes for some reason, like the hash that's stored might be 1234 on the server for the password, but if I go in there and change that to, and I send it to 12345, MD5 is going to know that I'm trying to send it a different hash, and it's going to send up an error and say, no, this is not right, this is not the password. So like, for example, if you had username and logon on a website, you only get so many attempts, and after so many attempts, you're locked out. So this kind of seems like what this would do when it comes to MD5. So would be a good be a good algorithm as far as speed, and the comparison to ensure the integrity is important, but it's not as secure because it doesn't deal with collision very well. MD6 128, Merkle tree structure for parallelism, more secure design, using multiple rounds of mixing compression. There's a source below for that. So then you have RIPE MD 128, 512 bits, dual parallel lines of 16 steps, different constants. Improved collision resistance. So you'll see a little trend on this is the better the function is, the less likely it is to have a collision. And that's the main thing we care about. But again, the more that you deal with collision, the more you prevent collision, the slower the algorithm is going to be as far as time, not time wise, but memory wise. It's going to take up more memory. It's going to bog down a little bit. So there is that issue, but it's going to be less likely to have duplicate hashes, which makes search a lot faster. So again, so another RIPE MD. So this one, when I was reading about it, it was very interesting to me because it's very secure. And if you look through the source, it'll talk about some of the testing that's been done. And so far, there hasn't been a test where it's found collision. That doesn't mean it doesn't exist, but they have done some rigorous testing on this and so far have not found any collision. So I feel like, based off of my reading on this, that this would be one of the better functions when it comes to how it's designed and how it works. So again, here's another SHA. So the standard for this, for many of those, is use compression functions to help prevent collision. Just what it does, well, all that means is like, the way to visualize that is if you were taking like all of our numbers in the universe, like from when we count, or from 0 to 9. Like we don't use any other numbers, even though we have 10, 11, 12. Those use base 10. So it would basically divide those up and compress them down to help prevent collisions. But it's not necessarily the most secure. It just divides them up. So the conclusion of this is they all of them have the O of N time, which is again the benefit of hashing and why we want to use them. But as this mentions, it depends on how you select which one you want to use. Is like, do you care more about speed or security? Um, like, do you care about memory? Do you care what is your main concern? If you're setting up a website and you have a username and password, you may want to use one of the more secure algorithms. And really, like I mentioned before, the salting method would probably be the best method when it comes to setting those up so that it consistently changes the hash even if multiple people have the same password. So here's another screenshot. Well, it's the same screenshot from earlier. I just wanted you guys to see it again from all the different hashes from some of the ones we talked about. And like I said, if you set up a username and password to randomly select one of these, you would never have the same hash, and that would prevent collision. And I think that would be the best way to set up a hash function, to set it up to randomly selected. And many of the videos mention that as well. So basically, like I said, you want to know what you're looking for when it comes to benefit versus risk. For setting up just like a dictionary, security of that, you may not be too worried about that. You don't want people changing a bunch of words in the dictionary and making them things that don't exist. Like Wikipedia is, a lot of people can edit that, and it's kind of open source, if you will. And so it's not the most reliable source when it comes to that. Uh, Also, like I said, when you're setting up a username and password, you want to make sure that you have the ability, I would say, using the salt method to change between the functions and what they do. So thank you so much for your time. I hope this explains a little bit about how hashing works and the pros and cons of each. And y'all have a great day.